Hey class, this is going to be an overview of lesson 1/2. We're talking about dilations. Dilations is something that you've seen in the earlier grades 6 and 7, but for today we are going to expand our knowledge. If you weren't here, pause and make sure you get the notes. These notes are what we wrote in class in our notebook. You do need to start a new page. Here is the second set. If you need to take it down, please pause the video, write down your notes. So in class, we talked about dilation, and dilation in geometry is the transformation that produces a figure to go smaller to the original by either shrinking or stretching. So it's either going to get bigger or it's going to get smaller. So if we look right here at a undilated pupil, for a pupil to dilate, in this case, get larger, okay? This pupil dilated to be larger. If we look at this whole PowerPoint slide, it's very large. What if we dilate it and reduce it? That is the opposite. There's two ways. It can either be enlarged or reduced. So if we took a look at this figure right here, same shape, same size, and we took the measurement of the diameter, we can shrink it using that measurement. We can decrease the size of the diameter to create the smaller one. Or we can increase the size by multiplying the size of the diameter. So we're just changing the size, not the shape. So in this case, if I looked at A, the shape changes and the size, so A cannot be it. If I look over here at Bart Simpson, I still have the same picture. It's just smaller. So I say C can be it. If I look here, they're the same picture again. Same shape, just different size. So B. If I look here, those pictures are not the same. So I can clearly say that B and C are dilations because it keeps the same shape and only the size is changing. Scale factor describes how big or how small an object will dilate. Is it going to reduce or increase? Center of dilation is the starting point, just like when we did center of rotation. Center of dilation is where the dilation begins. So if we looked at this character, Igor, he's teeny tiny. He wants to get bigger. He's 3 feet tall and by 2 feet wide. See the scale? And the center is right here. If we want to increase Igor, he wishes to be 6 feet tall and 4 feet width. Then he wants to be 2 times the size. Because if we look here and we multiply 3 by 2, I'll get 6. 2 by 4, 2 times 2 will give me 4. To get Igor's size to be double. So scale factors, if they're larger than 1, like we just did with Igor, he was 2. He went twice the size. Then they're going to get larger. But if it's under 1, then the scale factor is going to get smaller. So let's take a look at this. See this panda right here? If I wanted a scale factor of 1.5, okay, I'm going to see, is it going to get bigger or is it going to get smaller? Well, it's bigger than 1, so it's going to get bigger. B, this is going to be a scale factor of 0.75. Since it's smaller than 1, it's going to get smaller. And C, a scale factor of 3. If I was going to multiply this by 3, it's going to get bigger. Last one, this picture here, scale factor of 1/2. Well, 1/2 is smaller than 1, so that's going to get smaller. Just understanding that the objects, every size, it's going to be multiplied by the same number. If it's smaller than 1, it's going to decrease. If it's larger one, it's going to increase the shape. Here's some examples of some real life dilations. You know that video game is really big. These are little toy cars, so it's a decrease in dilation. It's a reduction. This is an increase in, because try sitting in that chair. So remember, dilations are enlargements and reductions. Okay, class, for the lesson on lesson 2, please check out the additional video. The video I just did was a quick overview of what dilations is. And you're going to watch Mr. Morgan's video. He explains the lesson for you to be able to finish your classwork. Good luck.